Welcome back to the beginner-friendly spring track. I'm your host, Bob Brinley, still with you, going to be with you all day. We're so happy to have our next presenters with us. They're presenting from around the world. We've got one presenter, Olga, in Poland. The other one's in Michigan, Spencer. So thank you so much for joining us. And I present to you Introduction to Spring Cloud, Olga Maciaszek-Sharma and Spencer Gibb. Take it.
Hello, welcome to our Introduction to Spring Cloud session. My name is Olga Maciaszek-Sharma, and I've been with the Spring Cloud team for over 2 years now. I mostly work on Spring Cloud Load Balancer, Spring Cloud OpenFeign, and Spring Cloud Contract, among other projects.
My name is Spencer Gibb. I have been on the Spring team for the past 6 years. I'm the lead of the Spring Cloud projects. Make a note of the Slack channel there. You can join us afterwards for questions. So let's go ahead and get started. Our goal today is really to talk about Spring Cloud and introduce some of the components and projects in Spring Cloud. But first, we're going to get a little background. We'll talk about cloud native applications. We'll show our demo architecture. And then after we introduce Spring Cloud, we'll revisit that architecture, kind of explaining how these pieces of Spring Cloud fit into our demo. So on to cloud native. So if you're unfamiliar with this term, it's a fairly recent term describing applications that live in modern clouds. Well, what does that mean? So to put an application into the cloud, it by nature means it's distributed. So there are many instances, and these instances can live in multiple geographic locations, right? Availability zones, regions, for example. These applications scale to meet demand, right? So instances come up. They also scale down if there's not enough need. Typically, these applications are built to be resilient, so they handle failure modes, whether it's instances dying or something's wrong with the database or something's wrong with the network or something's wrong with your cloud, whatever the case may be, they're built to be resilient. To do all these things, it's almost 100% the case that they need to be automated to do these things. There's also an organizational component to go with this, right? If you have teams that are in charge of different parts of your system, they want to be able to deploy independently and have their own continuous integration and deployments. And they're also replaceable because they're distributed. The technology behind them can be easily switched out without affecting other parts of the system.
So probably, many of you have heard about the fallacies of distributed computing. So they actually have been with us since the 1990s, and not that much has changed since. And even I would say they're becoming more and more valid because we are using network more and more as a first-class citizen of our systems and architectures. So the first one is that the network is reliable. It obviously is not. And not only is the network not reliable, but also other applications or other services that we might be connecting to via the network. And that is why we need resilience mechanisms such as circuit breakers. Then latency is zero. It obviously is not. That's why we need to have tools and need to be able to track the latency of our calls and our applications and verify where we have too much latency in our requests. We all know the bandwidth is not infinite. The next one is the network is secure. I would say network is as insecure as it gets. Then topology doesn't change. This one is particularly important now with microservices. So now usually we are just killing and spawning new instances across different zones, and we cannot expect any application or any instance to be all the time available under a certain host. So we need a central point, a service registry, for example, that tracks our topology for us, and we can query about this topology and get the actual addresses of the instances. There is one administrator, no, there's none, as we know, and then the transport cost is obviously important. And the last one, the network is homogeneous. It is not, and even within a system or a microservice ecosystem, we can have bits that are very different from each other. They communicate differently using different network protocols. So it's very different even within one system.
So another attribute of cloud native applications, or what are called 12-factor applications. This comes from our fine friends at Heroku. As they were building out their platform, they noticed that if the applications that run on them behave these certain ways, it made deploying to their platform much easier. And in general, this works with all cloud native applications. So a lot of these things talk about individual applications, and a lot of what Spring Cloud deals with is cross-process integration, really. But things like having your code and version control is very important. We will talk some about configuration. They recommend that it's stored outside your applications. They talk about things that we kind of take for granted now: continuous integration and continuous delivery. Having your logs print to standard out and standard error, those kinds of things. There are also other forms of factors. James Waters likes to talk about the one-factor app, which literally is just, can you restart your application, right? There are many journeys across becoming cloud native, and that is one. And our good friend Deshaun Carter also talks about 15-factor applications. So as you mature, there are more things that you can add to this list.
So we will be demoing a sample introductory architecture for you. We will have various services. There will be a card application service where a user can apply to get a credit card. Then a user service where we can register the user and we can verify both the application and the user through the fraud verifier microservice. So these services will use circuit breakers to make communication more resilient. They will be using client-side load balancer. We will have a service discovery or a service registry that they can query to get services. We have also added an API gateway and in between all the communication to route the calls. And we have a running configuration server that provides a centralized configuration for all the applications to use. And we have also added some metrics.
So first up, we get to talk about distributed configuration. So we built a config server based on talks we had with our friends at Netflix. They never open sourced theirs, so we went ahead and built one. And this is a process that lives in your system, and when services start up, they ask config server, can you give me the configuration that is appropriate for our current environment? So our Spring Cloud config server has pluggable sources. So we started with Git. Git is nice because it provides some things like versioning and the ability to roll back configuration. But then things have evolved over time. We support secrets from Vault, from HashiCorp or CredHub. We also support sources like a JDBC compatible database, and also we connect to various infrastructure services like S3 or other property or configuration services from different IaaS vendors. When you connect to config server, we have a retry mechanism set up. We'll talk a little bit about that later. But if it's not immediately available, we can make sure to try it again. And all this comes with a Spring Boot compatible starter. And we'll show you that in a little bit. But config server is not the only option for getting distributed configuration. Another example is Spring Cloud Console config. So where config server is a server that you run from Spring Cloud, this is a bring your own console cluster, but we have a client. We connect to the console key value store for configuration, and we can do this a value per key, or you can kind of treat it as a blob store and put your full application properties or application YAML in the keys. One of the nice things about console is that it is you can watch keys, and so we can set up auto refresh mechanisms so that if a key changes that you care about, your application's config can be updated automatically. And in our demo repo, there's a branch that supports console. By default, we'll show you config server, but there will be a branch that has console as well. There are additional ways that we can inject configuration. You can go to Vault directly. We also support Zookeeper, and then also direct to the stores from our different IaaS partners as well. And this doesn't preclude you from doing things like config maps that Spring Boot 2.3 added support for. So you can definitely use whatever fits your architecture the best.
So now on to service registration and discovery. As we've said, we usually don't know what is the actual address or the actual host of any given instance. And what we usually know is that we want to create request for a given service. And that service usually in a microservice in architecture will not be just running as a one instance. So usually we will have a set of instances that are handling that service. So in order to know where they are and also whether they're up or down, and what we can do is query the service registry and get the set or the list of instances for any given service, and then use whatever logic we choose to select one instance and then execute our request. So in Spring Cloud, we provide various options of working with service registries. So first one is Spring Cloud Netflix Eureka. This is a standalone Eureka server that you can run. It is highly available. It is, however, eventually consistent. If you're going to use Netflix Eureka, we strongly recommend that you do it through our integration, because even the authors of Netflix Eureka, so Netflix, do use it with via Spring Cloud Netflix, and you can read about this in their blog. We also provide support for Console by HashiCorp in the Spring Cloud Console project. It's again a bring your own console approach, and console can actually be strongly consistent. So this is not the default configuration, but you can make it so if you need to. We use Services API for console. We support console health checks, and we also provide a Spring Boot compatible discovery client for console. We also support some other implementation like Spring Cloud Zookeeper Discovery and Spring Cloud Alibaba, and actually in our demo code base, you can also find an example for Zookeeper discovery. However, even though you can just connect to service registry and query for service instances, you would rarely do so because it's a very repeatable feature. So what has appeared is client-side load balancers. So they would actually retrieve the instances of a given service for you and then use some kind of algorithm, for example, round robin, to select the right instance. They also often allow you to specify additional criteria such as zone or additional health checks, or they can support other options. So you would usually just use the client-side load balancer to redirect your request to a selected service instance. And the load balancing, client-side load balancing mechanism that we provide is Spring Cloud Load Balancer. It is a replacement for a very popular Netflix Ribbon project. However, the problem with Ribbon is that it was put into maintenance mode, so we could not continue supporting it. Instead, we are providing our own implementation. And if you're using Hawks, then you can still use Ribbon, but then from the next release trains, you will have to be using Spring Cloud Load Balancer because that only will be available. And then we provide a pluggable algorithm, so you can change service instance list suppliers that provide these pre-filtered sets of instances. And then you can also change the actual instance selection algorithm. For example, you can write your own and plug it there. And we provide easy-to-use builders. And we also provide reactive support. So actually, we support both REST template, load balanced REST template, but we also support load balanced web client builders. And we also provide extensible configuration for that.
So on to failure mitigation. As Olga talked about the fallacies of distributed computing, there are many, many things that we have to take into account. Instances that go up and down, network problems, whatever the case may be, we need to have strategies in place to be able to deal with these problems. So we've mentioned a circuit breaker earlier. So first, kind of to go over the diagram on the right, what is a circuit breaker? So it's modeled after a physical electrical circuit, right? So in your home, if there's an overload in your electrical circuit, the circuit breaker opens and power is off to all the things on that circuit, just so that your house won't catch on fire, whatever. So in a software circuit breaker, it's very, very similar. When the failure threshold, so many failures over this period of time happen, the circuit will open, and it will stay open for a certain period so that the failures don't cascade to other parts of your system. And then every so often, the circuit will try again, and as things get better, it will close back up and allow requests to continue on. So one of the things that's a little different about a software circuit breaker is the ability to offer a fallback. So instead of just throwing an error to the user, you can provide something meaningful to the user. For example, if you have a recommendation system and it's down, well, rather than show nothing, you could show either a static list of things or some random list of things. And so the user can still have an experience, even if it's only slightly degraded. We have a pluggable API that we use, that we created. We recommend Resilience for J as the default. Again, this is similar to Ribbon in that we recommend Resilience for J as a replacement for the excellent Hystrix library from Netflix. We also support our own Spring Retry, and there are also implementations from Alibaba, for example, using their Sentinel project. This can be used in either reactive or non-reactive scenarios, and it's a fairly simple API that we'll demo in a little bit. the next thing that we talk about is retry. So when you have a failure, whether that's an exception locally or some network failure or the instance responded with an error, depending on how you set things up, you might want to retry requests. You have to be careful here because especially with HTTP calls, the nature of them, it may be that your HTTP client received an error, but the actual request made it all the way to the end. So it actually succeeded. So you should only retry requests that are idempotent, so that if they happen again, it won't cause errors. We support a number of different scenarios and libraries for retry. We have our own Spring Retry project that's integrated to a number of Spring Cloud libraries. If you are doing a WebFlux application, Project Reactor has fantastic support for retry, and Resilience4j also has retry support.
Another very important thing to keep in mind when you start moving to distributed systems is you really need distributed tracing, because as you are going to have many independent services or applications running, and if you then log only what is happening in that application for a given operation, you will have big difficulty to debug and understand what is actually happening in your entire business operation, because any given operation can span across various of these applications, and you need a way to link the logs for that process together, so that you know that logs in an application A and logs in an application B all correspond to the same business operation. For example, if your user creates an issue with some process. So that is what distributed tracing is for. Distributed tracing will instrument your logs in such a way that they will have a sort of a correlation ID, or as we have in Sleuth, span IDs and trace IDs that allow you to link the logs for the same operation across various applications in your system. So the implementation that we provide is called Spring Cloud Sleuth, and it allows you to troubleshoot across a distributed system by instrumenting various libraries and frameworks for tracing. So we instrument Spring Framework, we instrument Spring Boot, and we also instrument the many Spring Cloud projects. And down there, you can see a screenshot from a Zipkin analysis. So you can, first of all, use the traces for understanding what is happening in your logs and linking them. And secondly, for understanding the latencies in your system. And what is used in Sleuth are traces and spans. So trace would be an entire operation that goes through different components of your system, and then spans would be the single bits of that operation, and you can see them being analyzed in Zipkin for their latency.
So in a typical distributed system, even more so nowadays, where clients to your system may live on some mobile network, they may be a device, Internet of Things, it could be a browser on a phone, it could be a browser on a desktop or laptop, whatever the case may be. The clients, are varied, and it would be very difficult for all of them to know how to contact each individual service directly. To mitigate some of this, there's a concept of an API gateway. Now, this can be done fairly simply using things like HA proxy to do just some basic routing. But what we're going to talk about today is an API gateway that is developer oriented. So in Spring Cloud, we have Spring Cloud Gateway. This is a follow-on to the support we had originally from Netflix in Zool 1. We decided that rather than trying to integrate Zool 2 and do all sorts of wheel reinventing, the Spring framework had all the pieces we need to make a fairly lightweight gateway. When we designed it, we focused on developer experience and the APIs that developers would use to customize Spring Cloud Gateway. So it's very easy to customize, to add your own filters and do things in a language that you're familiar with. So Gateway is nice in that it's just a Spring Boot app. So if you're familiar with deploying those, your API gateway could be the same thing. We also support all of these different components that we have been talking about. So one of the things you could do is store route configuration in Spring Cloud, config server, for example. And then as you add routes or change them, you can reload those routes and have, that way you can deal with whatever situation arises in the moment. We support service discovery. So you can say, hey, I would like to route to this service, and not knowing ahead of time what, where those instances are located, and we can use Spring Cloud Load Balancer to load balance to those individual instances. You can also set up a circuit breaker at this level, so your clients won't see, can be protected from failures. And if there are failures or problems, you can certainly set it up to retry. We support sleuth and tracing, like Olga talked about, so that we pass those trace and span IDs onto the downstream services. We also support advanced failure mitigation strategies such as rate limiting, so that you can protect your downstream services and the experience that your customers have throughout your application.
So going back to our demo stack, the client-side load balancer that we will use is going to be Spring Cloud Load Balancer. For circuit breaking, we'll use Spring Cloud Circuit Breaker with Resilience 4J. We will use the Spring Cloud Gateway app in the middle, and a Spring Cloud config server to take configuration from. And then we are going to be using, in this example, Spring Cloud Netflix Eureka server for service discovery, but on other branches, you can also see it implemented with other service registries. So I will switch to the code.
All right, so let's get into showing how to use some of these things. So first, let's talk a little bit about config server. First of all, you only need a single dependency to start with, Spring Cloud config server. If you go to Josh Long's second favorite place on the internet, start.spring.io, you'll find all of these options that you can search for and find, but you could search for config server and find that there. If the application itself is very, very simple. In fact, there's only a single annotation that you need to have. It's enable config server, and this will get you a running config server. You then need to configure the config server. So in this case, we are using Git, but we support a composite configuration where you could have information in Git or Vault, and depending on the application, it could pull from both places. So if I
let me open it for you.
Okay.
Yeah.
So she's going to open our config project. It's down a few more, I think. There you are. All right, so here we are. In this case, we have configuration for one of our services, card service. By default, we have our logging set to warn, but if we were to set the dev profile active, then we could change our logging to debug. So let's go back to the demo, and I'll show you a little bit. We are using the fabulous HTTP application as our local HTTP client from the command line, and I'm going to show you the card service application. So we've enabled actuator environment endpoint, so you can see what this application has for configuration. So if we go ahead and run that, and I'll scroll back up here, we can see all sorts of things from the environment or Java system properties. As we get towards the top, I went a little too far. I went way too far. Here we go.
Yeah.
Right, so here we can see that we have a property source that is loaded from config server with our logging level set.
Yeah, now let's have a look at service discovery. So first, let's see our server. And again, it is super easy to start with. So the only thing really that you need to do is, again, add a starter, this time Spring Cloud Starter Netflix Eureka server. And then what you need to add again is just an annotation that says enable Eureka server, and that's it. Of course, you need to have a Spring Boot up running, but then it will work out of the box with our configuration. And then in order to make use of that, you will need to get a client starter to your application. So here in card service, we have added Spring Cloud Starter Netflix Eureka client. And as we have it, we again don't need much more configuration. We can just inject it in our beans and start using it. So here I have a service that is actually using it. So we have a REST template, and then we have injected a discovery client instance via constructor. And what we are going to do is retrieve an instance just by directly calling. So we are actually going to retrieve a proxy instance. This is our gateway. And then we are going to use this gateway to send our call to the user's service application. However, as we've said earlier, you don't usually do it this way. So it's much more convenient most of the time to use load balancer, client-side load balancer for this. So in order to use that, you again have to add a starter. So if you add Spring Cloud Starter load balancer with the configuration that you get by default, you have a configuration that is using a discovery client underneath. And basically, how load balancer works, it does the calls to discovery client every time to retrieve the instance and its host. But we usually don't want to do this because that would be too much. So we provide an out-of-the-box caching mechanism as a default that if you know what you're doing, you can still disable, of course, and you can also change the different properties on it. But by default, you will get the cached version of the load balancer. And now let's see how we can use it. So first of all, we need to configure a REST template. So as we said earlier, that could be a web client builder as well. So we are just annotating it with load balanced. And then there's one more thing that we're doing here. So this is actually not required, but let's say for one of our services, in this case, fraud verifier, we want to use a different custom configuration for our load balancing. So this is the way to do it. And actually, if you set it this way, it will only be used to load balance calls that are going to fraud verifier and not to other services. And in order to get this done, remember that you shouldn't have an add configuration annotation because you don't want Spring Boot directly picking these classes for configuration. You want it to be picked by that other load balancer client annotation. So here is an example of a custom configuration. We are actually overriding the service instance list supplier by using a builder. So it is, as you see, very easy to use. We are going to use blocking discovery client because we are using REST templates. So if we were using something else, like a web client, we would just use with discovery client instead. And we are going to use with zone preference here because we want to be using instances that are in the same zone as the load balancing app if we can get them. So now if we see a client that uses it, here we are injecting it, and actually the load balanced annotation is also a qualifier. And now we have a load balanced REST template, and we don't really need to do much more. We can use it to query by service ID. Okay.
All right, so next we are going to talk a little bit about circuit breaker. So let's head to the user service. So first of all, again, show you how to bring this into your project. Again, searching on Spring Initializer for circuit breaker, you would find this. In this case, we're using the circuit breaker starter specific to resilience for J. There's one for Spring Retry as well. So then, again, hopping back to the class, here we are creating the default configuration for our all of our circuits. So they will all use this as their configuration by default. We create a builder, and here we're setting, in this case, we're changing the timeout from 1 second to 2 seconds. Typically the default timeout for a circuit is 1 second, but in this case, we want it to be 2. And then for all the other things, go ahead and use resilience for J's default settings. So we just wanted to update the timeout here. And what happens on timeout is that either an error will be thrown, or if you have a fallback, the fallback will be shown. So here, let's go ahead and show how you use a circuit. So you inject a circuit breaker factory, and then you simply call create. And the reason you call create is that there are, just like in a house or any building, there are multiple circuits. So in an application, typically for each operation you create a different circuit. In this one, we're calling it verify new user, and it simply takes a runnable. And so this is the operation that we are going to protect with a circuit. In this case, we're using REST template. But it really could be anything, and it really doesn't matter what goes in here. Typically, it's something expensive, and network operations are typically expensive, so those are the kinds of things you might protect with a circuit breaker. The second part of this is another bit of code that can be run, and this is the fallback. So again, if there's an error for some reason that happens during the run, and that error could be timeout like we configured, it could be REST template can't connect to this URL, it potentially could be even a error code response from this REST template, right? It depends on how you set things up, and they can all be configured. You can watch Ryan and Olga's talk about configuring Spring Cloud, which happened ironically before this one, but it will be available on video after. But in any case, or if the circuit opens, right? So if these error conditions persist for a certain amount of time, whatever the case may be, for any failure or if the circuit is open, the fallback will be be run. And it's interesting because you get the exception if there was one. In this case, we're just passing a static verification result. But like I said before, it's typically useful to do something that the user would find still informative. And we'll talk about the retry in another bit of our demo here in a few minutes.
Yeah, going on to distributed tracing, what you need to do, again, you can configure it and make it much more robust, and you can even configure spans manually, use the underlying Brave traces and so on. That's not something we'll be showing in this introductory presentation, but in order to just make it run and instrument automatically a lot of your libraries and Spring Framework, Spring Boot, and Spring Cloud projects, the only thing again that you need to do is to add a starter. So we have Spring Cloud Starter Sleuth, add it in the user service, and then also Gateway supports Spring Cloud Sleuth. So what we can do is, if we run some calls in our application, we have actually just processed a credit card application through this entire mini ecosystem. And in user service, we can see that we get some logs. And for the logs, we also get these brackets, and within them some information. So we have a service ID, then we have a trace ID, and we have a span ID. So now if we use this and we go to Gateway, we can actually look for it. I've already pre-queried it before. So you can see that you will get a different service ID, obviously, because our Gateway has service ID proxy. And then same trace ID, because that's the same business operation, and different span IDs than from what we could see in the user service client.
So next up is the gateway itself. So let's see, I went the wrong direction. So here's our gateway. Show you again what is required to get started with Spring Cloud Gateway. It's simple starter that you'll find on Spring Initializer. There is no annotation needed, right? So just a very, very simple Spring Boot application. Because if you don't configure routes for a gateway, nothing happens. So it's really a library. There are various ways to configure gateway. One is via Spring Boot's typical external configuration, right? Application.yaml. And here we have our fraud verifier route. We give it an ID because it's useful for debugging and seeing what routes are available. We give it a URI, so it needs to go somewhere. This could be a normal HTTP API or HTTPS API, but we've configured this specific URI, and I've used the term URI instead of URL because of this. So this particular scheme, LB, stands for load balancer, and this signals to Spring Cloud Gateway that you want to use the load balancer and service discovery to load balance across this service, right? So this is the name that fraud verifier registers in service discovery. In this case, we're matching the fraud verifier prefix in the gateway, but the service itself doesn't understand this prefix, so we are stripping it. There are also various things you can do. Besides stripping prefix, we have a set prefix filter. We also have other things you can do to modify the path. And then we talked about retry. In this case, there's a retry filter, and we are going to retry 3 times in this case. So we could put this, for example, directly in config server under proxy.yaml, and this could be loaded from config server if we wanted to, right? So then you could go ahead and add other routes, check that into Git, and call post to /actuator refresh here on the gateway, and those new routes would be loaded automatically. There's also a Java DSL where you can use to configure routes. So here you can see a route locator builder being injected, and we're creating another route called user service. And then using the DSL, similar to what we saw with fraud service, we are doing a path predicate, but in this case, we're doing some Boolean logic. Now in the configuration version, if you had multiple predicates here, because we don't do programming in YAML, they would just be ANDed together. But if you wanted to do more complex Boolean logic, there are other methods that you could use here, such as negate or, right? So you can do a pretty much arbitrary Boolean logic here. Again, we've added the strip prefix filter and a similar load balanced user service. So, and we've been showing you demos of the gateway this whole time. So all of our calls, all of our REST calls have gone through the gateway to the other services. So you've seen it. It's not very flashy, but it does work. We also have a commercial support for the gateway in Tanzu application service, and you'll hear more about gateway in tomorrow's keynote. So that is the end of our demo. Let's head back to the slides. So this is a brief demo and brief intro. It may be a fire hose of new information for those of you who don't know Spring Cloud, but it's only part of it. So what didn't we talk about in the Spring Cloud portfolio? A lot, actually. Spring Cloud Bus is a management bus, event bus, built on top of the Spring Cloud Stream project. This allows you to send messages to various services to do different things. I think Olga and Ryan show that in their advanced configuration of Spring Cloud, so you can check that out in there.
We show bus, OpenFeign, contract.
Perfect.
Yeah.
So OpenFeign is a declarative REST client that allows you to just write an interface, and it's fairly nice. You can share contracts for clients. They talk about Spring Cloud Contract, which is contract testing, so you can share contracts and do testing between your clients and services. Very, very nice. Oleg, our teammate, will be he'll be talking about Spring Cloud Stream and Spring Cloud Function tonight in the closing keynote, and then Oleg and I will be talking about that as well. So Stream is, if you think message-based microservices is a good way to put it, and then Function is using Java util function for as an interface to various things, including Stream. We'll be introducing support for our socket tomorrow. Spring Cloud Task. So this is, think Spring Batch in the cloud. And then Spring Cloud Dataflow. So this is our streaming platform. So pipelines and streams of data, as well as tasks, can be configured and managed through a project called Spring Cloud Dataflow. Most of these either have been or will be talked about during Spring 1. So there's a lot more to Spring Cloud than just these few things that we've gone through. So as we get ready to wrap up, here are some links. You don't have to take a screenshot. So join us in Slack for questions. And I've uploaded a copy of the deck already into the Slack channel. These are links to the various things you have seen today. So our sample app that Olga crafted is at that URL. The Spring Cloud GitHub org has links to all the source code for all these projects, and then the link to spring.io is for documentation and guides and all sorts of other goodies there. We will be hopefully linking to a number of these presentations during this spring one to that spring.io link there. And if you want to contact us, of course, we'll be on Slack for the duration of Spring 1, but also on Twitter. So that about wraps it up for the presentation side. Head to the Slack channel for questions and answers.
Thank you for listening.
I'm sitting. All right. Thank you so much, Olga and Spencer. That was amazing. Always great to see you, even if it is virtual. If you have any more questions, please head over to that Slack channel and you can start asking them some great questions. They are just so full of knowledge that I know they can't wait to share it with all of you, even deeper after this talk. Stay with us. We have two other amazing presenters coming up with Jay Bryant, I apologize, and Josh Cummings. Cannot wait for that talk. So we'll be back at the 5 minutes past the hour. So head on back and we'll see you in a few moments. Thank you so much.